We finished the last video needing to implement ideas fetch, so let's do that now. We'll start by writing some specs for ideas fetch. From the previous video, we know ideas update expects ideas fetch to respond to a class method named call, so we'll add a context block for that. And it expects call to return an array of business idea strings. Running the specs, we see that ideasFetch.call failed to return the list of ideas, so we need to think of a way to come up with a list of business ideas that we can return. The way we'll do this is to hit some search engines autocomplete APIs with a collection of queries along the lines of where online can I buy or what businesses sell. We'll then use the returned autocomplete suggestions for the basis of our business idea, as it's something people have been searching for. We'll keep the list of queries to search for in a YAML configuration file in our config directory, and we'll add an initializer in config initializers to load it into a constant when the application boots. We can now use the constant config to access our data as a hash. Now we'll map over the queries and search for each one. We'll abstract the idea of performing the search into a new object. And to increase the variety of business ideas we suggest, we want to be able to use multiple search engines. We'll use a separate class to represent each search engine. This search engine abstraction gives us the benefit of being easily able to support more search engines in future, as well as being able to use the search engine functionality elsewhere in our app. Back in our spec, we'll add another two expectations to ensure ideasFetch is correctly searching for results. When we call ideasFetch.call, we expect each of the queries in config to be passed to a new Google search. For this to work, we'll need to make sure we stub the new method on Google search. We'll do this at the top of our context block, as we need this method to be stubbed in all our tests, as we haven't yet implemented Google search. We'll have this stub method return a double representing an instance of Google search, which responds to results returning an array of business ideas. We can pretty much just copy paste this logic again to write our expectation that queries are also passed to Bing search. Running our test gives us uninitialized constant Google search, so let's fix that. And while we're at it, we might as well implement the Bing search class. Running our test now shows the expectation that we pass queries to Bing and Google works as intended. However, the results returned from ideasFetch.call is not in the format ideasUpdate expects. We expect a one-dimensional array, and we actually get a two-dimensional array, which we can fix using array's built-in flatten method. And we can remove the repetition of ideas by chaining on array's unique method. Okay, now our test pass. Let's finish this video by extracting the result of calling ideasFetch into a let block. Let blocks are lazily evaluated, unless you use letBang, but I prefer to stick to using regular lets. So in order to get our last two specs to pass, we'll need to call ideas in the before block. Finally, let's run all our specs so far and make sure everything still works. In the next video, we'll take a look at implementing one of our search engine classes.